about how to develop a PLC ladder logic for the given case study, and we have taken a case study to be a sequential process where uh, the program statement is being given as given in the slide. We use normally open and normally closed push buttons or used to start and stop the process. When the stop button is pressed, solenoid A energizes to start filling the tank. As the tank fills, the empty level sensor switch closes. When the tank is full, the full level sensor switch closes. Solenoid A is de-energized. The agitator motor starts automatically and runs for 3 minutes to mix the liquid. When the agitator motor stops, solenoid B is energized to empty the tank. When the tank is completely empty, empty sensor switch opens to de-energize solenoid B. The start button is pressed to repeat the sequence, and this is the given statement. And from this statement what we have understood is we have used two push buttons. One is normally open and normally closed push buttons, and the output coils are the solenoid A and solenoid B and agitator motor, three output coils, and two more sensors other than the push buttons. You have two more input sensors. One is the empty level sensor and the full level sensor. So with this understanding, we'll move on to how to write the PLC ladder logic. Here I have described this PLC ladder logic using the instructions of Allen Bradley PLC 5 SLC 500 PLC, and the left part of this slide shows the schematic diagram representation of the given sequential process, wherein you have a tank here, and this is the agitate motor to mix the liquid inside the tank, and this is the solenoid A which permits the entry of the liquid into this tank, and you have solenoid B which can be opened to remove the liquid from the tank, and you have two sensors, one to detect the full level of the tank, and an empty level is being detected using the empty level sensor, and this board shows the start and stop push buttons being placed in the control station. Okay, with this knowledge we'll move on to how to do the programming of this for this problem statement. So the first rank, can you see the first rank? You have a start push button that is normally open, and you have a stop push button that is normally closed as specified in the problem statement, that is being given to a control relay. Since we have used a push button and we need the control relay to be energized, we need to have a seal-in circuit to make the control relay to be active, right? Okay, so this control relay coil is being represented as the control relay contact over here, and once the start push button is pressed, the control relay coil will get energized, and that contact is being connected to the solenoid A, and if the solenoid A gets energized, gets activated, so that the fluid, it will permit the entry of fluid inside the tank. Once complete full level is reached, once the full level is reached, this normally closed contact of the full level sensor will open. So once it is open, there will be a discontinuity in this run, hence solenoid A will be de-energized. Okay, so this is how you are permitting the flow of the liquid inside the tank and sensing the full level capacity of the tank. Once this process is done, you have to start this motor, and they say that the motor has to run for 3 minutes. So for that you need to configure the timer. So once the full, just come to this run. So once this full level sensor level is reached, you are turning on the timer, and the timer is being set. As you know, this is the instruction for the timer instruction used in Allen Bradley SLC 500 or PLC 5. This 180 seconds, 180 into the time base 1 seconds represents 180 seconds, 180 into 1, hence it is 3 minutes. So we have set the timing for 3 minutes. Once 3 minutes is done, the done bit goes high. Done bit of this timer instruction goes high. Okay. So once this done bit goes high, this will cause this normally closed contact to open, thereby agitate motor stops. So initially when the full sensor is reached, agitate motor starts to run. So once after 3 minutes the agitate motor stops. Okay. So this is how you are making this agitate motor to make it run, turn on and off. Then comes the mixing of the liquid is done, and you have to remove the liquid from the tank. Thereby what you have to do, you have to operate this solenoid. So how this solenoid is operated? Okay. So one after 3 minutes, so D4:0 done, when this done bit goes high, this normally open contact will be closed and solenoid B is made active, turned on. So thereby it will remove the liquid, mixed liquid in the tank. And this solenoid B has to come to the closed position after once it is removed, once the entire liquid is removed. So how will you know once the entire liquid is removed? The entire liquid is removed once the low level of the tank is reached, solenoid B has to be closed. Okay. So that's why you have this empty level sensor that is being given in normally closed contact position. So once it is reached, once the empty level is being reached, this normally closed become open. Thereby solenoid B is closed, is brought to the closed position. Okay. So this is how you can write a PLC ladder logic for the above given sequential process. Thank you all for watching. We'll meet you in the next case study. Thank you all.